Okay, so we've set up the hardware components of our base receiver. Now what we need to do is start logging a base file. So I've gone into, you won't be able to see this on the video unfortunately, the screen isn't very clear, but what I've done, I've gone into the software which we use to control the GPS, which is called TerraSync. This is a proprietary software owned by the company Trimble that builds this GPS that we're using today. So once I have done that, I've turned on the GPS receiver, and at the moment it's just starting to see satellites. So it'll take a few moments for it to receive what we call almanac data from the satellites. That was the sound of it just doing it then, and to get a fix on the satellites. So this unit is very sensitive, so it gets a fix very quickly. And we also have the benefit here, one of the great joys of working in Arabia is you have these massive open environments. So even in an interdural setting here, we've got an enormous amount of sky for the receiver to see. That's very important, so we can get a good distribution of satellites, and we can maximise the number of satellites that it's able to see at any point in time. So at the moment this unit on its own is getting an accuracy of 5.6 metres, but this will improve throughout the day once we've started the base file, so it knows its location. And because it's staying at a fixed location all day, any information when the location changes, we know that this is to do with variations in, for example, the satellite clocks, and other factors that can affect what we call the pseudo ranges to the satellites. This is how the GPS calculates its position. Because this base rover is in a fixed location, we therefore know that any variations we see are due to these effects. The rover will also be receiving those same effects because, to all intents and purposes, because we're very close to the receiver, we're in the same atmospheric window, so the effects will be the same, and we're seeing the same satellites. So this is how we're able to use the base data to correct the rover data and to improve the accuracy of the rover data. And at best here we're receiving up to 1 centimetre accuracy, that's both vertical and horizontal. So we can get very accurate readings from this combination of the two systems. So that's how the base works in principle. So we've now got it logging, it's now seeing satellites, so we can start our base file. But just before we do, we want to just check a few things. So we check that the GPS is receiving information from the base, because these units actually have an internal GPS, so we want to make sure it's the information from that receiver and not the one inside the data logger that we're receiving, and it is. We can set various logging settings now. Because this is the base, we simply want it to be logging continuously throughout the day. We don't want to impose any constraints on it, so we just double check that that's the case. Now the most important thing that we have to record before we start a base file is the antenna height. So this is currently set at the height we had it from previous days. So what we need to do now is just measure the height from the antenna to the ground. We measure this from the base of the antenna. We can in fact vary where we measure it from, but this is how it's set up at the moment. So we will just place this on the ground. So we want this to be on the ground rather than on the top of our mushroom there, because it's from the ground that we want to measure. And then we can see what the height of that is. So this is currently at 1 metre 25 centimetres 5 millimetres. So I'll alter the antenna height. And we just, again, double check our settings. Okay, so now that we know that that's all set up, we can go into our data menu in this software, and we can then set up the base file. So the first menu asks us the file type, and it's by default on rover, but we actually want this to read base, so we can change that. It'll ask you the location, and that actually refers not to its physical location, it's the location on the data logger that we want the information to be stored. You have the option of putting in an SD card, for example. In this case, we're just leaving it at default, so it logs to the data logger's own memory. And then we just give it a file name. So in this case, we're going to call this base TAG, so for Tiz Al Ghada, of course, which is the site that we're surveying today. And we'll put a little postfix here of the date so that we're fully aware of which date this base data was taken on. So today is Sunday, the 24th of November 2013. So once we've filled in this information, we tell it to create a base file. It will again ask us to check our antenna height. So we've made sure we've changed it in the base settings, and it has populated the field with that information. So it is reading the antenna height we just measured of 1.255 meters. It asks for the type of antenna you're receiving. In this case, this is an integrated GPS beacon, and to double check that we've got the correct antenna, there is a part number on the base of the antenna, and there's a part number on the information here. So this should read 29653, and if we just look at the base of the antenna, there is that part number, which is 29653. So we know that it's recording the correct, it's using the correct antenna settings. So it then asks you where you've measured the height to. As you saw in the previous part of this video, we measured the height to the base of the antenna mount. So we then go next, and it'll ask the logging interval. Now, because this is the base, we want it to collect information all day, and ideally we want that information to be as high resolution as possible. So in this case, I've set the logging interval to 1 second. We always want the logging interval on the base to be better, or to be higher resolution than the logging interval we're using on the rover. So in this case, or at least equal to it. So we're just setting this to log 1 point every second, and it will continue to do that all day. We then have various other settings, which we're just going to leave at default. These are to do with the cutoff points for the horizon and various other factors. It then asks us to stipulate the correction output. Now, with this particular unit from King's College, we don't actually have the option for this to broadcast differential corrections to the rover, so we just leave that set to off. Then we click next again, and this is the point where it'll ask you for the location that it's over. Now, if I was setting up this unit for the first time on the first day of a survey, we'd just click an option for here, and it would receive the information from the antenna for the current location and populate these fields for us. However, to make sure that this remains consistent, and because this is a consecutive day, so we've done several days survey here, we want to make sure that it always reads that same information. So we actually go into this field and ensure that it matches the information from our previous days. And in this case, it doesn't, because we have it actually also surveyed on another site in the interim. So we need to make sure that we've changed these coordinate values and the height value back to what they previously were for this site. And this will just take a few minutes.